Welcome to The Explainer. Today, we're diving into Cardano, a blockchain platform that's doing things, well, a little differently. It's one that's built not on hype, but on some seriously rigorous, peer-reviewed scientific research. And this really is the core question that Cardano set out to answer. The whole idea is, why should you have to choose? Why can't a network be both incredibly powerful and secure, but also predictable and sustainable enough for real-world global use? All right, so before we can really dig into Cardano's solutions, we gotta understand the problems it was designed to fix, right? What were the big headaches that came with that first wave of blockchain technology? So the early pioneers were amazing. They proved this whole thing could actually work. But they came with some major growing pains. We're talking about just insane amounts of energy use, transaction costs that could go through the roof without warning, and this constant risk that power could end up concentrated in the hands of just a few big players. Okay, so that energy problem? It really comes down to two totally different ways of thinking. First, you've got proof of work. Think of it like a giant, super competitive race where all these miners burn electricity to solve a crazy hard puzzle. The winner gets to add the next block. It works, but man, it uses a staggering amount of energy. Cardano went down a completely different road with proof of stake. This is less of a frantic race and more like a lottery where stakeholders are chosen to validate blocks. It's a huge shift from pure competition to collaboration. And the result? It slashes energy use like you wouldn't believe. But it's not just about saving electricity. I mean, think about it. A network is only as strong as the people who actually run it. And if it costs more to run the servers than you're earning in fees, well, what are you going to do? You're going to shut them down. That's a massive, massive threat to the whole system's long-term health and security. It's a problem that absolutely had to be solved. So with all these huge challenges on the table, how did Cardano approach them? Well, instead of that classic move fast and break things mantra we see so often, they did the exact opposite. They took a step back, went to the drawing board, and embraced the slow, deliberate, almost academic path. And listen, that's not just some empty marketing phrase. For real. Think about this. Every single core part of the Cardano network started life as a scientific paper. It got published, and then it got torn to shreds by other academics before they even wrote a single line of production code. The whole point was to build something with the kind of reliability you'd expect from mission-critical engineering, not some weekend project. And you can see this methodical approach laid out so clearly in their roadmap, these 5 big eras. Each one builds on the last, tackling a new piece of the puzzle. You've got Byron, which laid the foundation. Then Shelley came along and made it decentralized. Gauguin gave it a brain, introducing smart contracts. Basho is all about scaling, making it faster and more efficient. And the final piece, Voltaire, that's about handing the keys to the kingdom over to the community. It's literally a blueprint for building a digital nation, step by step. Okay, so this brings us to their first huge innovation, the one that tackles those big problems of energy and decentralization right from the get-go. And it's all thanks to this unique engine sitting at the very heart of the network. That engine has a name, Ouroboros. It's the beating heart of Cardano, and get this, it was the first probably secure proof-of-stake protocol out there. So like we said, instead of that competitive energy-guzzling race, it runs a kind of lottery. It elects stake pools to create the next block, and their chance of getting picked is based on how much ADA, that's Cardano's currency, is staked in that pool. So how does Ouroboros actually keep everything secure? Well, it breaks time up into these chunks called epochs, and inside each epoch are smaller slots. You can think of a slot as just one single chance to create a block. Now here's the clever part. For every single slot, a leader is chosen completely at random from all the stake pools. This randomness is the secret sauce, because if nobody knows who's going to make the next block until the very last moment, it becomes incredibly difficult for a bad actor to plan and launch an attack. And what's really cool is that pretty much anyone can get involved. If you hold some ADA, all you have to do is choose a stake pool from your wallet and delegate your stake to it. And your funds, they never leave your wallet. You're not sending them anywhere. You're just kind of lending their voting power to the pool. And for helping to secure the network, you earn rewards. Simple as that. So what exactly is a stake pool? Just think of it as a super reliable server that's running 24/7, managed by a person called a stateful operator, or SPO. Its job is to process transactions and, when it gets chosen, produce new blocks. It holds the combined stake from lots of different people who delegated to it. And yeah, the more stake a pool has, the better its chances of being chosen. But the system is smart. It actually has incentives built right in to stop any single pool from getting too big and powerful. Okay, so we've got an efficient and decentralized engine. Check. But what about actually doing stuff on the network? How does Cardano solve that other huge problem? The one where transaction costs are all over the place and things just fail for no reason on other platforms. The magic trick here is something called the Extended UTXO model, or EUTXO. Now, the best way to wrap your head around this is to think of it like this. Bitcoin's model is like digital cash, plain and simple. Cardano's model, EUTXO, is like digital cash, but each coin can have smart instructions attached to it. So these little outputs carry not just value, but also data and even complex logic. And this simple difference creates a night and day experience for anyone using it. On other systems, it can feel like you're buying something online, but the shipping cost and even whether it's in stock is only figured out after you've already hit pay. It might be what you thought, or it might be 10 times more. With Cardano's model, you know the exact cost and you are guaranteed it will work before you ever submit the transaction. No more of those awful surprises. And here's why that's just so incredibly powerful. Since everything is predictable, a developer can literally run a transaction on their own laptop and know exactly what's going to happen. If it works on their machine, it is guaranteed to work on the main network. For anyone trying to build a reliable, serious application, that is an absolute game changer. But hold on a second. What's to stop someone from just spamming the network with a bunch of transactions that they know are going to fail? Well, that's where this really clever feature called collateral comes into play. When you submit a smart contract transaction, you also put up a tiny security deposit. Now, if your transaction fails on the network, that deposit gets collected to pay the node operators for their time. It basically makes spam attacks way too expensive to be worthwhile. And this is the most important part for honest users and developers. You are never at risk of losing your collateral. Why? Because the outcome is deterministic. It's predictable. Developers can test their code thoroughly and be 100% certain it's going to succeed before they send it. So collateral isn't a trap for regular users. It's a shield for the network against bad actors. All right. So we have a network that is secure, efficient, and predictable. But what about the long game? How does it survive and evolve for decades without a central company making all the decisions? And that brings us to the final and maybe the most ambitious piece of this whole puzzle: community governance. This is what the Voltaire era is all about. It's basically creating an on-chain government, complete with a separation of powers. You've got DREPs, who are basically representatives elected by the community, the ADA holders. You have the SPOs, the stake pool operators, who represent the network's core infrastructure. And then you have a constitutional committee, which acts kind of like a Supreme Court, making sure all the rules are followed. It's a whole system of checks and balances baked right into the protocol itself. And this isn't just for show. This governing body has real power. Through different voting combinations, these groups can decide on, well, everything. From funding brand new projects straight out of the treasury to changing the fundamental rules of the network, all the way up to initiating a major software upgrade. It means the community truly, literally holds the keys to Cardano's future. But, great ideas cost money. So how does this community actually pay for all this future development? Well, a set portion of all network rewards, this 20% you see here, is automatically funneled into a community-run treasury. It's like a built-in, self-sustaining war chest that ensures there are always funds available to pay for the network's own growth and upkeep forever. Which leaves us with this one final, really powerful question. By building this entire system on a foundation of hard research, of predictability, and now community control, Cardano has set the stage for a future that is truly decentralized. What the community chooses to build with these tools, Well, that's the next chapter, and it's just waiting to be written.